this equation 1 is called as a circuit load line, right? So you can determine both.
Okay, sir.
So both the values we can consider as the independent variable, like I and Vi. We can calculate what is the value of diode voltage, what is the value of current. So suppose if I put I equal to 0 in this equation, okay, when the current is 0, so what will be the value of what is the voltage across the diode? The entire input voltage appears across the diode, right? So Vd will be equal to Vi, right? Vd will be equal to
Yes, sir.
Vi. And once I put Vd equal to 0, when the diode voltage is 0, I can get I will be equal to, what is the current? I will be equal to Vi upon RL, right? So you can see that, so I get the value of these intercepts, right? The slope is -1 upon RL. Slope of this straight line is a -1 upon RL. So don't think that I have drawn like this. You may also draw up here, you may draw here. It depends, because it's a graphical method. Everyone can think in a different way. So idea is basically that at the point at which it intersects with the this characteristics of the diode, that is called as an operating point. So we fix our operating point. This operating point may also move up and down, right? Because we are talking about the static characteristics. So the static means it is fixed. This input voltage is not, we are thinking that the input supply is fixed. It is not varying. But if this varies, then this will also shift. That is called as a dynamic characteristics. We will come to that. So so this is basically a load line. So you can see that, so you have determined the intercepts here, Vi upon RL, okay, and so this is a voltage across diode, this is the current. I hope it is clear.
Sir, please
Yes, sir.
take
Yes,
sir.
sir.
Pardon?
Hello, sir. Sir,
Pardon?
please take us to the last slide, please. Last question.
Large,
I have to
large,
write. The last slide.
last slide. I will share it immediately. Don't waste time in this. I'll share that. Yesterday also I have shared. Today also I will share whatever I will cover. Right?
No, sir, I am writing, so I wanted to write.
I will just share, or you can record it. Huh? You can take a screenshot. Right? So so the slope is -1 upon RL. Hai? The slope is -1 upon RL. Is it clear? So so the same thing. This is about and what will be the resistance, because this is a dynamic static resistance. I told you static resistance was there was a static resistance, there is a dynamic resistance, and there was a reverse resistance. So for a static characteristics we have a static resistance that will be equal to this voltage V equal to IR. So that means I and V is given to you, you can find out the R. So that is static. Now this was a graphical method. Somebody can place like this, somebody can place like this, but the same thing you can do analytically. So how do we do analytically? Suppose I have just chosen, I have to find out what is the value of Vd, what is the value of Vd, and what is the value of I, right? So I want to find it analytically. So how we will find out? For a case of ideal diode, I have taken that like Vi is given as 6 volt, RL is 1 kilo ohm, right? So for an ideal diode case, what will be the current value? Because I equal to Vi upon RL. Please respond.
Yes, sir.
So
Yes,
this is
sir.
6 milliampere, right? But if it is a silicon diode, I will be equal to Vi minus Vo upon RL. So 5.3 milliampere, right? Now you just see.
Yes, sir.
So what will be the current value from the other Shockley equation? If I try to find out, I will be equal to I naught e to the power V upon eta Vt minus 1, right? So I considered that I naught is very small, right? I naught is very small as compared to I. So this portion, this I naught we have neglected, and so it will be equal to I naught e to the power V upon eta Vt, because if you multiply, it will be I naught this portion minus I naught. So I considered, because it's a reverse saturation current and its value is very small, so I just assumed that as compared to I, that value is very small, so we neglected it, right? So this is this, and we know that what is the value of V equal to Vt log I upon I naught to find out, because we have to find out the voltage, right? So V equal to Vt log I upon I naught. So Vt we know 26 millivolt at the room temperature, log I upon I naught. I have taken I as 6 milliampere. I naught is, as I have taken, as 10 picoampere, right? Just this I have considered, that let IO naught equal to 10 picoampere. So I got a value of 525.5 millivolt, right? Now the same thing I have done for the silicon diode. V equal to Vt log. I have taken this value of current, right? Instead of 6 milliampere, you can see here I have taken 6 milliampere for a case of an ideal diode. This is for a silicon diode, which is 5.3 milliampere. So I calculated it is 523.15 millivolt, right? Now what will be the value of current? Now the value of current is, if I calculate 6 minus 0.523 instead of 0.7, right? The value of Vd came out to be 523. So I calculated the current again. So it comes out to be this value, right? And then once I know this current 5.477, I can again calculate it. Are you following?
Yes, sir.
Yes, sir.
Yes, sir.
This is the way we calculate it in the analytical method. Means because our aim is to find out Vd and I, right? So some values are given, so we can calculate, or graphically if we have to do, we have to simply put the intercepts, and you have to remember this equation that you can derive from the using the Kirchhoff's law from this circuit, and you can put it in this and you can determine easily, right? If the same values you put here, you will get the same results, similar kind of results, not exactly the same, because here the things are varying, right? So you will get the similar results, right? This is an analytical method. You can perform analytical way also. This thing may not be asked in the exam, right? Analytical method आपको नहीं पूछा जाएगा. Only thing is that I am just telling you that this is also the way we do it analytically, right? And
Hello, sir.
yes, please.
Please explain the last V and once more.
Last,
After I equal to I naught V by NBT. After
this
what
eta
is it?
equal to 1, because if you remember, eta equal to 1 for germanium and eta equal to 2 for silicon. That is basically the diffusion coefficient, diffusion rate, right? It defines the diffusion rate. So just from this equation only, I just take out V here and Vt log I upon I naught. इसी equation को मैंने इसको ऐसे लिखा, eta का value 1 लिया, right? Consider eta equal to 1 and I naught equal to 10 picoampere, and just put this value here. So this value here I am considering this I value as for ideal diode, right? If it is an ideal diode, right? It will depend on which diode you will be using. So this ideal diode I have in case of an ideal diode, this is this. So the Vd comes out to be 525.5 millivolt. But if I consider it as this diode, silicon diode, and taking this value of current 5.3 milliampere, then putting it in this equation, I get this value. So once I get the value of V, I have again put this value of V in this equation and calculated I, right? And this equation and calculated I, because this is what the voltage across the diode, right? So what do you write? Vi minus Vd. यही तो लिखते हो ना आप, Vi minus Vd divided Vi minus Vd, right? This is the input voltage minus the voltage across the diode divided by the resistance. So that gives you the value of current. So you get the two intercept. I you got the V also, right? You got the voltage across diode, you got the current across diode flowing through the diode, right? So this is analytically we have done. Similarly, if in the previous case we thought that my input signal is not changing, but suppose now my input is changing, the input which I applied is changing. Suppose you have to determine that the change in diode voltage and diode current when the input Vi is changed from 6 volt to 6.06 volt. So suppose if your input is changed from 6 volt to 6.06 volt, so you have suppose plotted for 6 volt, right? And then when the input was 6 volt, then your input changes to 6.06 volt, because once you are applying an AC signal, like there can be a variation in the input signal. So once there are variations in the input signal from 6 volt to 6.06, so then this, so for these two changes, when the input was 6 volt and when the input was 6.06 volt, I've just taken an example. So then you may notice the change, that the two load lines, and this is called as a dynamic curve, because the input is changing, right? There is a change in the input. So when the input is changing, the change the input voltage, then the this is your voltage is also changing, right? The voltage across the diode will change, the current will change, flowing through the circuit will change, right? So we will find out the intercepts based on that, in that from the same equation, one that I have told you in the previous class. And in this case, the resistance will be the dynamic resistance, because there is a change in the input voltage, the diode voltage, and there is a change in the diode current because of the change in the input supply voltage, right? So this is called as the incremental equivalent resistance of the diode. So so you can see that almost near Q point, these characteristics becomes linear. Okay, if you want, you can replace it with a equivalent circuit or a resistance, right? So it is the same thing. What will be the value of current? ID plus change in the current, diode current. Similarly, voltage across diode will be VD plus change in the diode voltage, right? Input voltage is changing, Vi plus del of Vi, right? So the change in the input voltage. Are you following this? Nothing but only thing is that
Yes, sir.
whenever the input signal will change, this load line will be changing, right? The operating point will change, and because of this change, this so 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 what happens basically, because of there are many other factors also in the circuit, like the temperature is a big thing, right? So when the temperature, due to the temperature effect, this Q point shifts, right? This Q point automatically shifts, right? So we need to, because we determine, our aim is to fix this Q point to a point, to a point on the on this characteristic curve, so that we should get a maximum faithful output, right? But due to the change in temperature, right, applied input voltage, this Q point varies, right? Not in dynamic case, but in static case also this Q point varies. So if this Q point shifts, like suppose if यहाँ आ गया, then you may not get the required output, right? So we need to fix. So we fix this Q point in some reason, and that is done basically by providing the biasing of the circuit. So we do the biasing of the circuit. We will study these things later, right? So that the Q point shift should not be there. So Q point should remain stable, right? So then if the Q point remains stable, we will get the maximum faithful output and without loss, right? So that is called as a dynamic load line, AC load line, right? And the same thing is depicted here also, right? For the same circuit, this is called a transfer curve. So when you plot, don't there is nothing difficult in this. Don't see we say it as a transfer characteristics, right? Transfer characteristics, right? So if this is a transfer characteristics, we say that there is a relation between V out and V in, right? Relation between V out and V in is called as a transfer characteristic. So you can see that this is the input signal given. So this is plotted on a time axis, right? Here, right? This is a time axis t. So this is an input signal we have plotted. You can see that there are different time instants are mentioned, t dash, right? Then I can say t1, t1, t2, I can say, and you can see that this is what. So this is the input signal at different time instants t, right? Here this point, then, and these points are marked because this is as per the application of the input signal. When it is below v gamma, you can see when the input is below v gamma, right? uh, you are not conducting. So once it exceeds v gamma, the diode starts conducting, right? The diode starts conducting, and as you go keep on increasing the diode voltage, the current starts increasing, right? So all these points are marked on the transfer curve, right? Are you able to see it?
Yes, sir.
एक बार फिर से बताइए.
जैसे this is what, as I told you, transfer characteristics means the relation between output voltage and input voltage, right? So if I have plotted my input voltage in this way, right? अगर आप वैसा डायग्राम होने से और भी बड़ा हो जाता, so this is an input voltage, right? So at different time instants, you can see that if you see that at this point, right, this point is shown here. So we have put some different instants of time, okay, on the input of the input signal. So you can see that if I consider this portion, right, this value is v gamma, right? Below this, once you are applying this input, right, there is no change. There is no change in the there is no diode output, right? Means current is not increasing. The characteristic curve. This is the characteristic curve of the diode, right? So this is not changing. But once you increase from v gamma, right, if you exceeds this, the current starts increasing, right? And once you increase this input voltage, right, what is the change in the output? So this says what is the change in the output. So accordingly there is an output. So this is the maximum. Then during the positive half of the cycle, because what will happen during the positive half of the cycle, when you have the input supply like this, no? So during the positive half of the cycle, क्या होगा आपका? When during the positive half of the cycle,
Lower one will be disappear.
हाँ, so this diode will conduct, but during the negative half of the cycle, what will happen? During this period of
No
time,
conduction.
diode will get reverse biased, and
Yes, sir.
it will not give any output. So that is why it is shown like this. And then once again there is an input signal, so you will get this maximum this way, right? Can you say I just ask you one thing, anybody can try in multisim and then can answer, right? If I say that, if I say reverse bias, right, आप बोले कोई करंट फ्लो नहीं करेगा, बट लेकिन अगर आप प्रैक्टिकली देखोगे, राइट,
तो थोड़ा होगा.
it will,
So some micro amps of current will be there.
now if you increase the frequency, if this signal is of higher frequency, right, if I say this signal is of higher frequency, you will find that there will be some small current, right? There will be some current. This portion will not be clipped properly. Even there will be some current. Can you say why this current will be there?
Minority charge particle.
नहीं, माइनॉरिटी चार्ज पार्टिकल तो ठीक है, रिवर्स सैचुरेशन करंट तो बहुत छोटी होती है ना, बहुत माइनर होती है, बट आई एम सेइंग इट विल लुक लाइक दिस. Even maybe the replica of the input signal also, if you are going for a very high frequencies. Can you say, you just try it and then I will answer that. क्यों ऐसा हो रहा है? Because it is happening because of the capacitances. because when you go at very high frequencies, you can try it in the multisim. When you go at very high frequencies, what happens? Xc equal to 1 upon 2 pi fc. So once you are going at a very high frequency, this reactance becomes 0, right? And once this reactance becomes 0, the current starts flowing when you go. Are you following or not? I'm talking at high frequencies. You can try it in the multisim and can check when you are going for a very high frequency what kind of response you are getting it, right? So this is about the transfer characteristics. So nothing to be worried about this, because it shows only it shows a relation between bolo.
So which type of question will come from this topic, sir?
Load line means, like I can tell you that if suppose I am giving you that there is a variation in the input voltage 6 volt to 6.06 volt, plot the load line. इस तरह का क्वेश्चन तो नहीं आएगा, because अभी तो it will be multiple choice questions, right? But you should know how to plot it, because suppose if I am giving you a question like this, that I'm giving this load resistance as 160 ohm, right? 160 ohm load resistance and a DC supply of 10 volt, right? 10 volt. So you have to draw a DC load line and determine the voltage drop across the diode and diode current. ठीक है, आपको DC लोड लाइन प्लॉट करना है और बताना है कि डायोड वोल्टेज और डायोड करंट का क्या वैल्यू होगा, राइट? आप कर सकते हो ना इसको?
थ्योरेटिकल क्वेश्चन भी आएंगे ना?
थ्योरेटिकल क्वेश्चन भी आएंगे, हाँ।
टोटल कितना क्वेश्चन आएगा?
I think 20 क्वेश्चन होना चाहिए. I not yet. I will confirm everything by next class, right?
Okay, sir.
You may expect there will be 20 questions. मतलब इसी टाइप के जैसे हम लोग कर रहे हैं, और क्या न्यूमेरिकल्स है ना, और कोई कहाँ से लाएगा और क्वेश्चन, है ना? इसी टाइप के क्वेश्चंस होंगे, और क्या. सो तो समझ गए ना कि अगर if this voltage is given as 10 volt and RL is given as 160 ohm, you can plot the load line. You can simply put it in this equation, DC load line, if I am saying. So you can, what will be the value of VD? VI is given, right? RL is given. So you can put I equal to 0. So you will get VD equal to VI. Is it not? So VD will be equal to 10 volts. VI कितना है? 10 volt. And when VD is 0, you will get I equal to VI upon RL. VI is given as 10 volt, RL is given as 160 ohm. So you will get 62.5 milliampere. So you can, so once you are plotting this curve, how will it look like? It will look like this. There will be a, you can say that 60, I can say 10, 20, 30, 40, 50, right? Then 60, then 70. तो यहाँ पे कहीं 62.5 होगा, है ना? 62.5, and there will be a static characteristics of the diode, and here this side it will be 10 volt. So I can say 0. ठीक है, थोड़ा सा गड़बड़ हो गया, मतलब you can assume 4, 6, 8, this will be 10. So this way it's very simple, no? You have put, so this will give you the value of I, and this will give you the value of VD, right?
Okay, sir.
Okay, nothing else. Okay, so now we are moving.
Sir,
Yes.
in analytical method of finding the load line, and you considered the silicon, and the newton of silicon is 2.
Okay, then you put it as 2. By mistake I had taken it 1. It should be 2, right? You're right. Just I showed you that this is the way you have to do it, because then it requires a lot of calculation, you know, and graphical method is easy. So now we are moving on to the next topic, that is Zener diode. So I told you about the two types of breakdown mechanism that occurs in the reverse bias region of the operating characteristics, and this there is one is avalanche breakdown that happens due to the collision of ions, and this Zener breakdown occurs due to in case of a Zener breakdown, the depletion region is very thin. It is very highly doped. PN junctions are very highly doped. P type and N type are very highly doped, and the depletion region is very thin. And in reverse bias, a strong electric field exists, and because of that, the covalent bond breaks, and this the charge carriers moves from valence band to the conduction band, right? And that gives rise to a huge current flow through this. So this portion, like in the reverse bias, this characteristics and the diodes and the PN junctions employing that Zener breakdown phenomena is known as Zener diodes. So as compared to the previous diode, the symbol is different. You can see the symbol of the Zener diode is different because this is kind of a JAD you can see, and this Zener is basically the name of a scientist who discovered it, who was basically studying about this breakdown mechanism of semiconductor insulators, right? So he was this name came from the name of the scientist who discovered it. So the symbol looks like this, right? This diode operates in the reverse bias region, right? This diode operates in the reverse bias region as compared to the ordinary diode that we have seen that operates generally in the forward region, and a very small conduction occurs in the small current flows in the reverse bias. But this diode is intentionally designed to and I told you one more thing, that in case of a Zener breakdown, the breakdown occurs at very low voltage levels like 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, right? So they are because this breakdown voltage is based on the concentration of impurity added in the P type and N type. So that determines basically at what voltage level the Zener will break down. So this you can see the characteristic curve of so above this we do it is never used. You can see that there is a knee kind of thing I told you, right? So this knee where the voltage becomes constant, and a current flows. So this is there is a minimum current IZ min, and there is a maximum current. I told you that is called as an IZ max, beyond which you cannot go, because I told you that if beyond which if you are going, because it is mentioned in the manufacturer's sheet that beyond which you cannot go because the diode will burn because of the dissipation. So there is a value of PZ max, that is a maximum power dissipation by the diode. That is nothing but PZ max is equal to VZ multiplied by the IZ max. So what is the maximum current that flows through the diode? So there is a minimum current that is flowing in the reverse bias in the Zener diode, and there is a maximum current, and this region from minimum to maximum current is known as the operating region of the Zener diode. The Zener works only in this region. So this diagram is not proper. I can tell you that I just want to show you. So this portion where exactly this looks like a knee now, this looks like a knee. So this is a breakdown voltage, and this portion, this is IZ minimum, and there will be a IZ max, right? And that IZ max will be dictated by the sheet, right? Because VZ is constant, because the voltage remains constant and the current increases rapidly, and this current can increase up to a maximum level, because if it goes beyond that, it will result in the destruction of the diode, right? So we can have Zener diodes which can have a breakdown of 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, whatever you want you can have. That will depend on the combination of the impurity, that concentration of the impurity added in the PN junction, PN N type. So the PN junction which follows the Zener breakdown mechanism are known as Zener diode. Their symbol is like this, right? It operates in the reverse wise. Now let me just take, and Zener diode has got one application as a voltage regulator, right? So let me just draw RS. Vi. See, you know that we have this input supply voltage. See, when I am saying as a voltage regulator, right, I am expecting that as regulated output voltage is appearing. Suppose जैसे हमारा मोबाइल का चार्जर है, right? You put it in your AC supply and you get a regulated DC output of 12 volt or 5 volt or 24 volt, right? You get that. But if it is, suppose if it is not regulated, means if it is fluctuating, if the input supply is fluctuating, there are many chances that your device will get burned, or there are many chances, like, so what should be the, so for that reason we use this Zener diode for as a voltage regulator to provide a fixed output of fixed voltage output. The voltage remains constant, however the current changes but the voltage remains constant. So generally you connect a load. Load means the appliance which you want to regulate, right? This can be a part of a power supply. This portion can be a part of a power supply, and the load or the appliance which you want to connect, you connect it here. So that is usually referred as a load. So we connect it as a RL, right? And we want a constant output voltage, because generally हमारा क्या होता है, AC supply होती है. AC supply को we give it to the transformer make it step up or step down, and then we use diode to convert it into the DC supply. So once it is DC supply, if I am saying if it is a DC supply, it is an VI is a unregulated DC supply, क्योंकि जब हम लोग उसको डायोड लगा के रेक्टिफिकेशन करते हैं, AC to DC कन्वर्जन करते हैं, then that is not pure DC, right? That is, there are some ripples into it. Okay, that means the input supply is not like this. There are some ripples into it, right? So so even though we put different type of filter capacitances we put to remove these ripples, but still it is not pure DC, right? So there are some variations in the input supply. Are you following? If you are not following,
Yes, sir.
please stop. So if so there are variations in the input supply. It is not like a DC. DC should be like this, but it is not like that. There are variations. Though we put, yes. Yes.
Sir, after unregulated DC supply, what you said, please repeat.
I am talking about what is unregulated DC supply. I am saying that generally we connect our devices to the AC supply directly, right? So so when we are connecting our AC to AC supply में there are variations. कभी-कभी देखते हो ना आप, वोल्टेज बढ़ते हैं, घटते हैं, right? और कभी-कभी क्या हो जाता है कि कई बार हमारी बहुत सारी चीजें फूक जाती हैं, राइट, खराब हो जाती हैं, क्योंकि वोल्टेज वेरिएशन बहुत ज़्यादा हो, कभी बहुत हाई हो गया, कभी बहुत लो हो गया, ऐसा होता है ना अक्सर. तो अभी तो ये इशू कम होता है, लेकिन पहले बहुत ज़्यादा होता था, राइट? तो जब इस तरह के इश्यूज होते हैं तो जैसे हम लोग क्या करते हैं कि अगर हमारा ये डीसी सप्लाई है, जैसे हमारा जो चार्जर का बात आप कर रहे हो, लैपटॉप चार्जर और मोबाइल चार्जर, so this we say this is a DC, right? But why I am saying it is unregulated DC? Because it has got some ripples. Ripples means some AC components are present in this, right? Ripples means just like this kind of, right? It's not pure DC. There are some ripples in the input. So because of that, your device may get damaged. So what we want, though we put some sort of after rectification means after rectifier out in the rectifier output, when where we get the DC, we put some filters to remove these ripples, but still there are some ripples still exist. They cannot be filtered out. So we need to have some mechanism so that we can have a regulated output, means of the power supply, so that it should not vary, right? Because if it is varying, it's not good for our appliance. We want a regulated output. So our VI is unregulated DC supply, okay, and that may vary. That varies from some कुछ minimum होगा VI minimum to VI maximum, right? उसका किसी एक range में vary कर रही है, right? So similarly, as you know that the when this diode operates in the reverse bias, right? This diode operates in the reverse bias, and once it is operating in the reverse bias, you can see this voltage is fixed, this voltage is constant, Vz is constant, but the current is increasing, and this Iz min to Iz max is the operating range of the Zener diode, right? As I said, beyond this, if you are going, there will be higher dissipation, higher power dissipation, and will result in the destruction of the diode. And this knee point where the voltage becomes constant, this is the minimum current that should flow through the Zener diode. So Iz min, Iz max, right? So if there, when you are applying an input signal which is minimum, there will be some value of Is. What will be the value of Is? Vi minus Vz. Vz is constant. Vi minus Vz upon Rs, right? What will be the value of? Because based on the supply voltage, because if your supply changes, supply voltage varies, this current will also vary, is it not? So suppose if your supply voltage is at minimum, this current will be minimum. If your supply voltage is at maximum, the current will be maximum. So accordingly, for Vi min and Vi max, I will have Is min to Is max. The current will also vary. The supply current will also vary. And what will be the value of Is min? Can you say? I said Vi min minus Vz divided by
Rs. Rs.
अच्छा, अगर हम बोलें कि Rs भी वेरी करेगा तो, because there can be a Rs minimum also, because this is a design problem.
R maximum.
R max minus R min.
By R max.
Rs min क्यों होगा फिर? मैक्स क्यों होगा?
मिनिमम चाहिए सर, इसीलिए
मिनिमम चाहिए, राइट? सो मैक्सिमम रेजिस्टेंस टू Vi max minus Vz, because this is constant, Rs min,
R minimum.
राइट? सी देखो, ये एक डिजाइन प्रॉब्लम है, राइट? सो देयर वी आर डिजाइनिंग a regulated output. तो इसमें देखो, ये अगर मैं इनपुट सप्लाई, these are there are various factors which can vary. तो आपको वैल्यू क्या होना चाहिए, you have to decide. So this is what we are doing, that when the input voltage is changing from Vi max to Vi min to Vi max, so the supply current will change, and the value of supply current will also depend on this Rs. So if this series resistance also changes, right, from a minimum value to a maximum value, so what will be the value of Is, right? And you know that IS will be equal to what in terms of current? I can write IZ plus IL. लिख सकता हूँ?
Yes, sir.
Yes,
तो
sir.
यहाँ पे देखो मेन फंडा क्या होता है इसका कि this because you know that once you increase this voltage, the diode voltage becomes constant, but the current maximum current flows through the current increases rapidly, right? तो जैसे आपका जो सप्लाई वोल्टेज जब आप बढ़ा रहे हो, right, when there is a input you are applying, there will be some diode current flowing through the G-nut diode, right? There should be a minimum value of G-nut diode current IZ min, then only it will conduct, right? And it can conduct up to IZ max, right? So if I am saying this
Sir.
IZ, yes.
Sir, IL will always be constant. Then
What will be
IL.
you may no, it will also depend on the load now. IL will not
RL if RL constant, then
if RL is constant, but RL can also vary. Now you have different types of appliances, right? So I am coming to one by one, right? First, let us see. So IZ, so IZ can also be IZ min to IZ max, right? You can see from the in this you have seen now there is an IZ min, there is an IZ max.
yes, sir.
So I can say that IZ can also be in the range of IZ min to IZ max, right? What you are saying, IL will be constant
If
if
RL is constant.
RL is constant, but it may also vary, right? So
Okay,
if it is so, you will have IL will be equal to VZ upon RL. If IL is constant, RL is constant, right? So from this equation, can I write from equation 1, I can write IZ will be equal to IS minus IL. अच्छा आप बताओ अगर I am saying that I want a minimum current to flow in the diode, in the G-nut diode. So what should be the value? So it should be minimum
RS
or
maximum.
IS minimum, na? IS minimum and IL
Maximum.
right. Similarly IZ max क्या हो जाएगा? IS
Maximum minus minimum.
max IL minimum. क्योंकि देखो टोटल करंट तो फिक्स है, so if the maximum current is flowing through the G-nut diode, because IS value is fixed, if the maximum current is flowing through this, then the minimum current will flow through the load resistance, right? And if उल्टा कर लो अगर if there is a maximum current flowing through the load resistance, ऐसा कब होगा जब maximum current IL maximum कब होगा? जब RL का वैल्यू क्या होगा? हायर होगा या लोअर होगा?
लोअर होगा.
Lower होगा, less resistance. When the load resistance will be smaller, then the maximum current will flow through the load resistance. In that case, IZ will be minimum, right? So because RL is not in our control, RL can also vary from minimum to RL min to RL max, right?
Yes, sir.
So now which parameter is left out? RS. Okay, already I have told about RS. So RS can also vary from RS max, RS min to RS max, right?
Max.
So now there can be three cases generally. If I say there can be three cases, so are you following this? Because if because this supply current is fixed, so if the whatever current is flowing through this, it will depend on the load resistance, that how much IL is flowing through it, and based on that, if it is IL max, so minimum will flow through it. If this is and the voltage remains constant, this voltage across diode remains constant, right? So let us see how does it work. I have taken one example. So I've just written if RL is constant, IL will be equal to Vz upon RL, and IS will be equal to Vi minus Vz upon Rs. If RL is constant, right? IS, the same thing is written over here. IS min, right? The same thing we have discussed. Now, I just want to take one example that suppose initially this is a power supply, right? Which gives you an output of a 10 volt output, and to regulate it, because as I said, there are variations in the supply voltage, we need a constant power supply. So what we have done, we have put a shunt resistance Rs and then a Zener diode, right, between these 2 points A and B. And if we have to connect a load, we can connect a load across this point, right? In between we can connect RL, right? So that the constant voltage and Zener breakdown voltage is 5 volt, right? So initially I am considering that I have not connected any load. So since this is VA equal to given as 10 volt, right? This 10 volt, and RS, the current IS is flowing through RS. So this voltage is 5 volt across the Zener diode. So what will be the voltage across this? These 2 points.
So again, repeat question, please.
See, this is in this we are considering that we are designing a power supply. There is a power supply. As I said, that there are variations in the input supply, right? VA is 10 volt, but there are some ripples. We want to have a regulated output. So what I have done in this power supply, this is a part of a power supply only, right? This is a part of the power supply. So what I have done, I have put this resistance Rs and Zener diode, that is to be operated in the reverse bias, and I have put, and this Zener diode has a breakdown voltage of 5 volt, right? So if I have to connect a load, what I will do, I will connect a load across this in order to have a fixed output across it, right? So initially I am not considering any load. I am not considering any load, right? I'm not considering. What I am considering, that this input, this power supply is giving me a 10 volt output, right? 10 volts. Breakdown voltage is given to you as 5 volt. Vz is given as 5 volt, and the power ratings are given as 2 watt. Pz max is given to you as 2 watt, right? That is the Pz max. That the max, that from where, because Vz is fixed, you know, Pz max is Iz max into Vz. So Vz is constant. Vz is constant. It is given as 5 volt. So you can determine what is the value of Iz max. Because 2 watt,
0.4 ampere.
400 milliamperes, right? I just want to show you with this example that how this works, right? You just see the values, how they will change. So so what is the voltage across this point? Voltage drop across RS. What is the voltage across RS? 5 volt, right? So you can 5 volt. So you can so what should be the minimum value of RS? That will allow the maximum current to flow, because we are talking about IS is only Iz. So that the maximum current can flow through the diode, Zener diode. So what should be the minimum value of resistance?
So 12.5.
12.5 ohm, right? Now let us say we connected a load. We connected a load. We calculated the value of RS. There is a voltage across RS is 5 volt. The voltage across Zener diode is 5 volt, and we connected an RL of 1 kilo ohm. Let us say, okay. Now you see that current through 1 kilo ohm resistance क्या होगा? What will be the value of IL? What is the voltage across this? 5 volt divided by 1 kilo ohm. So
Yes,
IL
sir.
will be 5 milliampere, right?
Yes, sir.
So what will be the value of current IS? IS will be 5 volt divided by 12.5 ohm. So that is 400 milliamperes, right? So current through the Zener diode क्या हो जाएगी? 395 milliampere. Is it not?
IS minus IL. Yes, sir, yes.
Yes, sir.
Yes, sir. Yes, sir.
ठीक है, voltage remains constant. Now this 10 volt supply, because of the variation in the input supply, this 10 volt changes to 8 volt, right? Are you following? I have this, because of this, let
Yes,
us say
sir.
power supply is giving me an output of 8 volt instead of 10 volt, right?
Okay.
Yes.
सर सॉरी टू बॉदर यू बट सर कब तक क्लास चलेगी? एनएसएस का डिबेट है हमें।
Actually in that case it will go up to 4:30. कितने बजे से है आपका? At what time?
अभी था हम लोग का सर 4 बजे से स्टार्ट था तो इसलिए सर।
अच्छा तो जैसा आप बोलो, फिर तो जैसा आप लोग बोलो, I can stop it, but we have to we will not be able to finish it because if time will be less, I won't be able to do the numericals on Zener diode.
सर रिकॉर्डिंग ऑन करके कर दीजिए।
अगर ऐसा है कि how many of you want to go to this NSS?
सर मोस्ट ऑफ द स्टूडेंट्स बिलोंग टू एनएसएस तो।
सर
Yes.
एनएसएस का डिबेट सर वही है जो 20 स्टूडेंट क्वालिफाई किए उसी के लिए है बस, और किसी के लिए नहीं है सर। सबके नहीं है सर, सबके लिए नहीं है सर।
Okay, then what we can do, we can record it, and Rishika, you can have any doubt, you can ask. हाँ?
रिकॉर्डिंग ऑन कर लीजिए सर, बाद में देख लेंगे।
सर तो जिसका वो जा सकता है क्या?
हाँ, if you want, if you have this debate, you can go, please.
Yes sir, thank you sir.
Because otherwise we will not get time.
जब पढ़ाओगे फिर हम लोग सब मिस कर लेंगे जिनका नहीं है, जो नहीं कर सकते अटेंड।
तो फिर बताओ कैसे? Because otherwise we will not get time, no? When we will get time? Then Saturday, Sunday, you are also having some other this other clubs recruitment and other things.
Sir, recording कर
जैसा बोलो, because if I don't have any problem in recording, and if any doubt is there, you can ask. All 20 students are from this CND.
Yes sir.
तो ठीक है, 5-10 मिनट हम लोग करते हैं आगे, ठीक है? उसके बाद हम छोड़ देंगे, फिर हम लोग कल कर लेंगे, ठीक है? जस्ट मैं ये वाला प्रॉब्लम एक बताता हूँ और एक दो प्रॉब्लम बताता हूँ। तो लेट अस से पावर सप्लाई बिकम्स 8 वोल्ट, है ना? मैं रिकॉर्डिंग में डाल देता हूँ। I'm not saying anything like if you want I will repeat it for you, but only thing is that there should be a separate time, okay? I will repeat. So if suppose power supply changes from 10 volt to 8 volt, now what will happen? Your IS will change. What will be the value of IS? Because now if this power supply has become 8 volt from 10 volt, voltage across Zener will be how much? 5 volt.
5 volt.
So remaining voltage will appear across this RS 3 volt.
Yes sir, 3. Yes sir.
So now what will be the value of IS? IS will change to 3 volt divided by RS का value, RS is 12.5 ohm. So IS value will become 240 milliampere, right? And then
Yes,
if you see, because the load is constant, IL will remain same. IL will remain same because load is constant, 1 kilo ohm.
yes.
So IL will remain constant, but our IZ will change. IZ will change to IS minus IL. So that will be 235 milliampere. So you can see that whatever be the variation of power supply voltage, the current in RS will fluctuate, but the voltage across the RL will remain constant. So this is the basic principle of regulated power supply. But you should also remember one thing, that whenever you are going for this, the supply voltage must be greater than the Zener breakdown voltage. then the supply voltage, if the supply voltage, suppose if it is 3 volt, then this Zener diode will not work, right? The supply voltage should always be higher than the Zener breakdown voltage. Is this clear? Up to this? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so I am just already some numericals already done. I have done to speed up the things. So don't see the solution part. Okay, they just say you have to, this circuit is given to you, right? This is the case when the supply voltage is fixed, right? RL is also fixed, right? RS is also fixed. All the parameters are fixed. They are not varying. This is the case for that. So in this case, and the Zener diode is given with a breakdown of 48 volt, right? So you have to find out the output voltage drop across RS, current through Zener diode. Can you say output voltage? What will be the output voltage? So the output voltage will be what? Whatever you have across this. So that is 48 volt. VL will be 48 volt. Similarly, voltage drop across RS. So that you have to find out IS. So what will be the value of IS? 120 volt minus 48 volt. 128 volt minus 48. So that is the drop across RS. 72 volt. Now the third point is current through Zener diode. So what will be the value of IZ? IS minus IL, right? Because IS equal to IZ plus IL. जिसको नहीं समझ में आएगा प्लीज पूछ लेंगे. So IS will be equal to how much? IS is 72 because the voltage drop across RS is what? 72 divided by 5 will be the current through RS, right? IS minus, so IS you calculated, IL you calculated, IL will be 48 divided by 10 kilo ohm. So IZ you can calculate. So this type of is it okay? It is it you got it?
Yes, sir.
Yes, sir.
Okay. Now now you just imagine a scenario where this input supply voltage has changed. Input supply voltage is having a variation from 100 volt to 200 volt. It's a variable supply, right? So in that case, you have to determine the minimum and maximum value of IZ. Because if the supply voltage varies, what are the parameter? Other parameters will vary. Can you say?
IS, IL.
Sir,
IS will vary, right? Since the load is fixed because there is no variation in the load. RL is not varying. So load current will remain fixed. Yes, IZ will, there will be minimum maximum based on, because IS will vary. There will be a maximum IS, there will be a minimum IS based on the supply variation, right? So if that is changing, the IS is changing, obviously IS equal to IZ plus IL. So this will also change because IL is constant, but there will be a value of IZ will vary from minimum to maximum. Is it not?
Yes, sir.
So you
Yes,
can
sir.
determine. So you can determine Vs max is how much. What is the value of Vs max? Vs max will be how much? 150 volt.
200
volt.
150.
So Is max you can find out that Vs max upon, since यहाँ पे Rs is not varying, so Rs is constant, so we are writing simply Rs. Otherwise, if Rs is also varying, then Is max equal to Vs
By
max. Rs minimum हो जाता, right?
Yes, sir.
Yes, sir.
Since Rs is not varying, so we have written Vs max upon Rs. So we got this value, right? Then IL is also constant because our load is fixed. So IL is V out upon RL, right? 5 milliampere. So now what is the value of IS minimum? IS minimum will be 100 minus 50 divided by 5 kilo ohm, right? So that is 10 milliampere, and IS max equal to IZ max plus IL min. So IZ max will be IS max minus IL. So that will 25 milliampere, just putting these values, and IZ min will be equal to 10 minus 5. It's because IS min, IZ min will be equal to IS min minus IL max. So since there is load is fixed, so IL is fixed 5 milliampere, right? So we will get this IZ and IL.
Excuse me, sir.
Yes, yes.
In the last question, you have write that there IS max. Sir, in the last question, sir, after this,
यही तो
after this,
question.
sir. No. Sir, this question we are doing.
हाँ. क्या पूछ रहे हो आप? What are you
Sir,
asking?
so you have right now IS max equal to IZ max plus IL mean. तो वहाँ पे IL max ना होगा, mean नहीं होगा ना?
कहाँ पे? ये यहाँ पे? ये जो यहाँ पे बोल रहे हो आप?
सर जहाँ पे आप स्टेटमेंट लिखे ना IS max equal to IZ max
प्लस IL min. हाँ. तो बोल रहे हो आप यहाँ पे min क्यों होगा? ये पूछ रहे हो ना? ये पूछना चाह रहे हो ना? See, generally when I am saying that this is IS, the current is total current is constant, no? So if I am saying that the maximum current flows through this zener, so that means the minimum is flowing through this, no? The maximum flows through this, then the minimum will flow through this.
Yes, sir. Minimum flow through load.
Since यहाँ पे load RL is not varying, so IL is constant, right? Similarly, if you see, if I say that if I have to say IS minimum, IS minimum means if I say IZ minimum, so if I am saying IZ minimum means what? The minimum current is flowing through zener, so that means what? The maximum current is flowing through the load, so that will be IL max, right?
Yes, in that case IL max.
Yeah, we have written it now here. Just you see that IZ min will be equal to IS min minus IL max, because the maximum current will, if the zener current is minimum, that means the maximum current is flowing through the load, and if the zener current is maximum, then the minimum current is flowing through the load, right?
Okay, I understood.
Okay.
Thank you, sir.
No issue. So okay, you just see this numerical. I will upload with this and some other numerical also here, this numerical also, or I can say it is very simple. So you have to design a zener regulator, right, to provide a regulated voltage of 6 volt. So it is given, the zener voltage, regulated output voltage is given as 6 volt, right? So for a load current, now you see who was asking that the load current varying from 1 milliampere to 20 milliampere. So that means your load is also changing. So there is a minimum load current and there is a maximum load current.
It's not.
Huh?
That means the resistance of load is not constant.
Not constant, right? It is varying. Because you may connect you may have different appliances. Now sometimes you are connecting one appliance, sometimes different. So you have the variation of that load variation. So input supply is also varying from 10 volt to 15 volt. So you have a input supply is also varying, and based on that your IZ is also varying from 0.1 milliampere to 50 milliampere. IZ min, IZ max, right? तो आप बताओ what will be the value of RL min and RL max आप निकाल सकते हो कि नहीं निकाल सकते हो? Don't see नीचे मत don't see here. You just tell it is given, output regulated voltage is given, right? Consider that circuit, this circuit or any circuit you can consider this circuit. So there is an RL mini, RL max. right? IL min, IL max is given to you. Vi is varying. Vi min to Vi max is varying. Iz min, Iz max is given to you, right? So can you find out what is RL, because this is given to you 6 volt. VO is given to you 6 volt. So RL min क्या हो जाएगा आपका? RL min क्या हो जाएगा? बोलो. RL min क्या होगा? 6 by IL max.
and
6 by IL.
6 by IL max, right? और RL max क्या हो जाएगा? RL max will be 6 by IL min. Is it not?
Yes, sir. Yes, sir.
So the same thing is written here. RL min is V upon IL min. Sorry. Yeah.
Sir, here that regulated voltage is given, that is VO.
So VO is given, right? So you will calculate RL min and RL max. Now, what else is required? You have to calculate RS. How will you calculate RS? You have to first find out the value of IS. IS कैसे निकालोगे? You know IZ, you know IL, so you can calculate IS max and IS min. So once you calculate IS max and IS min, you will you know VI max and VI min, so you will calculate RS max and RS min. ठीक है, ये आप निकालोगे. We will discuss it next class. ठीक है, I will share it immediately. The PPT I will share. Right. Similarly, this question determine the range of RL and IL that will result in maintaining the V out of 10 volt. So V out you have to maintain. The RL is a variable one, right? VS, the supply voltage is fixed. RS is fixed. General voltage is given as 10 volt. IZ max is given as 32 milliampere, right? So since the supply voltage is fixed, you can calculate IS equal to VS minus VZ upon R. So that is you can calculate 40 milliampere. Is it not? Since IZ max is given to you 32 milliampere, IZ max, so you can calculate IS min. IS min is what? IZ min plus IL max. So what is IL max? IS minus IZ min, because IS though it's not varying because the supply voltage is not varying, it's fixed. So IS is constant, right? Minus IZ min. So IZ min is what? IZ max is given. So you can have this the maximum current flowing through the Jenner. So you can find out the IL max. So that is, so the minimum current is assumed as 0, right? The minimum current that is assumed as 0. It is assumed that it is the minimum current through the Jenner is assumed as 0, right? So that is 40 milliampere IL max. Corresponding load resistance will be RL min VO upon IL max. So you will get VZ upon IL max. So that you will get 10 upon 40 milliampere. So that will be 250 ohm. Another question was you have to find out this PZ भी निकालना था. PZ, the power dissipation. So that is VZ into IZ max. So IZ max is given. So VZ is given. So you can calculate this PZ, right? Is this clear? Question is clear?
Yes, sir.
Yes, sir.
This type of questions can be given to you where the supply will vary, RS will vary. So you should be clear that how you will do it, right? I will also, I have some more questions. Okay, we will do it in the next class, no issue, because some of the students are missing it. We will do it tomorrow. Okay? I will upload this part. I will upload this part, right? Sorry for bothering you on this date, but because syllabus we are not able to finish now. The quiz will be on 2nd. It is decided. It will be on 2nd. So and there will, आपका कोई अभी एक आध क्विज तो हुआ होगा, एक आध कोई क्विज हुआ है?
नहीं हुआ
नहीं हुआ सर।
नहीं हुआ सर।
ठीक है, अगर हमारा
ही पहला है सर हम सर क्विज में क्या
थोड़ा
क्या है
आसान रखिएगा सर, थोड़ा
नहीं
आसान
तो हम
रखिएगा।
लोग हम एक आपको